Okay, Algebra 2 students, this is a factoring review. So we're going to start by taking out a greatest common factor. 16, 8, and 20 all have a common factor of 4. So we're going to take that out. Then you want to check and see if all of the terms have an x. They all have at least one x. So you're going to put the x next. And then check for the y. They all have at least one y. So we're factoring out 4xy. So then you have to think 4 times what would give you the 16, and that's a 4. You have x to the 1 here, but you need to make x to the 3, so you need x squared. And you have y to the 1, but you need y squared, so you have another y, and the y times the y gives you the y squared. Next, bring down the minus. 4 times 2 would give you the 8. X times another x gives you the x squared. And you already have the y, so you don't need another y here. So then 4 times 5 is going to give you the 20. You already have the x that you need, but you need y to the 3rd here, and this is just y. So you're going to put y squared here, and then when you multiply this times this, it should give you this one here. Okay, for problem 2, anytime you see 1, 2, 3, 4 terms, you want to think about factoring by grouping. So when you factor by grouping, you split them into 2 pieces. In the first group, 4 and 24 have 4 as a common factor, and they both have at least x squared. So you're going to take out x squared. 4x times x would give you 4x to the 3rd. Sorry, 4x squared times x. And 4x squared times 6 would give you 24x squared. Then you look at the second group. The second group has a common factor of 3, and they don't both have x, so you can't take x out. 3 times x is 3x, and 3 times 6 gives you the 18. So when the insides of your parentheses match, you know you're on the right track. That's one of your factors, x plus 6. And the other factor is the outsides, the 4x squared and the 3. Alright, problem 3 is an example of difference of squares. The pattern for difference of squares is a squared minus b squared equals a minus b times a plus b. So this is already a square, and we need to make the 49 into a square. So I can write this as x squared minus 7 squared, because 7 squared is 49. So that means in my pattern, everywhere you see a, you write x, and everywhere you see b, you write 7. X minus 7, x plus 7. Alright, problem 4. The number in front of the x squared is 1. It's 1x squared. So this makes it the easy kind of factoring. In the easy kind of factoring, you want to find 2 numbers that multiply to give you 16 and add to give you negative 8. So numbers that multiply to give you 16 might be 1 times 16, 2 times 8, 4 times 4. But if you add these, you're not going to get negative 8. So what you need to do is stick a negative sign on each of them. Negative times negative is still positive 16. And now you can see that if you took negative 4 and negative 4 and you added them, that would give you the negative 8. So these are the numbers you want, and because it's the easy kind of factoring, because this is just 1x squared, you can just write your factors right away. X minus 4 times x minus 4. Okay, problem 5 is the same kind of problem. You need 2 numbers that multiply to give you 40 and add to give you 13. So I just like to list all of the numbers that multiply to give you 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8, and then you can find the pair that adds to 13. It's this pair. So you can just write x plus 5 times x plus 8. Alright, so if you haven't been stopping the video between each problem, you should be doing that. You should try the problem before you watch the solution. So this is the same kind of problem. I need numbers that multiply to 24 and add to negative 11. So I'm going to make a list of numbers that multiply to 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. None of them add to negative 11, so stick a negative on them and you'll find a pair that does. Looks like this is the pair. Negative 3 times negative 8 gives you 24. If you add them, it makes negative 11, and there's no number in front of the x squared, which makes this the easy kind of factoring. X minus 3, x minus 8. But then you get to a problem like number 6, and there is a number in front of the x squared, so this is going to be a little bit longer. You want numbers that multiply to the first times the last, so they have to multiply to negative 30. And they're going to add still to 7. So multiplying to negative 30, negative 1 times 30, negative 2 times 15, negative 3 times 10, negative 4, no, that doesn't work, negative 5 times 6. Alright, so of these numbers, the ones that add to 7 are negative 3 and 10. But you can't just put them right into the factors. Instead, what you're going to do is break up the 7x to be negative 3x plus 10x. So I'm going to have 6x squared minus 3x plus 10x minus 5. And then you factor by grouping. So you look at the first two. They have a common factor of 3, and they both have x, so you take that out. 3x times what gives me 6x squared? Well, 3 times 2 is 6, and x times x gives you the x squared. 3x times what is 3x? Well, that's just going to be 1. In the second pair, they have a common factor of 5, so I'm going to take out a 5, and I have 5 times 2x will give me the 10x, and 5 times minus 1 gives me the minus 5. So the insides match, that's one of my factors, and then the outsides are my other factor, 3x plus 5. Alright, in the last problem, we're trying to find two numbers that multiply to negative 3 and add to 5. So numbers that multiply to negative 3 would be negative 1 times 3, or 1 times negative 3. And those are the only choices. Neither of those add to 5. So this is prime. You cannot factor it. Down here for problems 9 and 10, when it says factor completely, that's a clue that you're looking for a greatest common factor, and then you're going to factor some more. So if you look, all of these terms have an x, so you can factor out an x. And then you can continue to factor. So numbers that multiply to 5 and add to 6 are 5 times 1.